This is part 4, I think, of this series where we do a Treemap Viewer over the weekend. And I decided I was going to put this in Codex View so as we can hook it up to the program visualization that we have. Now, I started to think about what that would mean because, you know, we would be making nodes based on a different kind of data. So far we've been doing the files, right? And instead of files, this would be things in your program, which means we'd have nodes for modules and all sorts of things. And, you know, this made me realize there's a few things that I didn't do. So for example, there's no user data fields on the Treemap node or on the display node. All right. And I feel like when I add a node, I'm going to want to be able to have that. So I'm just going to put 3 fields on there because why make it complicated and weird? User data pointer, right? User data int, user data float 64, right? So if you just want to put some random stuff on there, you could do that. All right. So that's fine. Now the question is, do I want to put separate things on the display node? And I feel like the answer is let's not do that yet. But anyway, let's just make sure this still compiles. Great. So, well, that was easy. I think I'm going to put this into a separate module now that could both be loaded by this example and also by the Codex view. So since we're going to put it in a module, I don't know, would you call it fitting? I don't know what it is. Okay, so anyway, we're gonna put some words. We're gonna say this is a module for making squarified tree maps, which is a way of visualizing data in 2D. This module does not actually do rendering of the tree maps. It's just here to help you make them. Yeah, so later if we put a tree map renderer in GetRect, it might use this module. Okay. Okay. I should turn off the lights back here, right? They probably not good. And this is maybe a little too intense as well. I don't know. Can't wait till I get my good camera back. Okay. To create a tree map, first, just say first, what do we do? First, somewhere you have a default initialized tree map struct. Then you call add node repeatedly on this tree map. The first node is the root, which must have a null parent argument after that. Each parent must be a previously added node in this same tree map, not a different one, okay? Don't be fucking around with that. The returned tree map node has a few user data fields for you to use as you wish. Location in okay. So when we add a node, do we set dirty? We don't, but there we go. Like, yeah, I don't know. Okay, so the return tree map node has a few user data fields for you to use as you wish. When you are done adding nodes, call recompute if dirty on the tree map. Here, we're going to assert itself is dirty. The user did not update it. And that is bad. Assert that that's not dirty. All right. Call recompute if dirty on the tree map to initialize its hierarchy info and compute sizes. To draw a tree map, call init Treemap Display to return to you a Treemap Display corresponding to a particular tree map. Call recompute if dirty on the display, on the tree map display. With outer size representing the 2D area in whatever units you want, perhaps screen pixels, representing the 2D area into which the tree map will be packed. The data in Treemap Display is, I don't want to say orthogonal, I want to say is independent of Treemap, except that it points back at it, thus requiring it to exist. So you can have many Treemap displays for one Treemap if you want. The Treemap display contains an array of display node where each of these gives you the positioning of that rectangle in the tree map. Display node doesn't contain any coloring or texturing properties because we don't really know how you will want to display things. You can use display node.node.user_data star or store the pointer to each Treemap node as a key in a hash table with some rendering properties as the value, or whatever you want. The Treemap fitting performed here is based on the paper Squarified Tree Maps. Okay, so what else do we want to tell people? Well, right now we don't bother cleaning up. Right now we don't bother giving you away to free tree maps. We might do that eventually, or maybe you should allocate them in a sub-allocator that you can eliminate in one go. Okay. Have I run the tests after the exception fix? I have not. That's a good point. Oh, we should tell people about the example. I was wanting to do that. Okay. For an example of how to do this stuff, see examples Treemap. Modules codex view, or is it examples codex view? Hey, look, it worked. So examples codex view also uses this module. What happened? I hit control period. Okay, that's, that's about 10 times more documentation than people usually write. So that's fine. Okay. So let's just make this a module. Now, do we want to make it a single file module? Or not? If we make it a multi-file module, we could put the example in the module, which might be better for people. But maybe just as a data structure module, we want to keep it lean. And maybe the example would be more like for the UI part. I don't know. This assumes the display and building calls are single-threaded? No. What? What do you mean? What do you even mean by the display and building? Do you mean they're serialized relative to each other? No, we don't assume that. So you can create the tree dirty it in parallel to calling the display function? No, there is no display. What do you mean display function? There's recompute if dirty, which again, you're only going to call this one. You're only going to call this if your window size changes. Or you don't call this to render anything. This produces a data structure that you render on your own, so it doesn't have anything to do with anything. Like, I feel like you're coming from this perspective where it's like, oh, every library has to have fully reentrant data structures so I could do anything. And it's like, that actually sucks. It sucks because it makes everything really slow and complicated. And in reality, if you wanted to synchronize this, you could by putting some simple mutexes outside of it in a couple of places, right? But like, just thinking about if you want to display while still querying a slow hard drive. Well, you can either... So you mean, you know, let's say it takes 5 minutes. Let's say it's a giant hard drive and it takes 5 minutes and you're getting new nodes in another thread or something. Yeah, in that case, what you would do is you would call add node to the tree map, right? That would mark it as dirty. Once you've added a batch of nodes, whenever you felt like, you would call recompute on it. Now that said, what we haven't added, so the recompute does the whole tree map, which is probably instantaneous for any reasonable size of tree map you'll ever want to look at. But if you had a really giant one, we would probably just go implement add node that incrementally modifies the tree map to propagate the size upward, right? Because that's actually kind of easy. Like all you do is you add the size to the parent nodes recursively. We just don't do that right now. Because the size, we actually don't know the size. We assume that you might change it or something, which I don't know. But anyway, so you would call recompute and then you would refresh the display struct. And yes, you wouldn't want to do those things while you're attempting to add new nodes, right? So you would have to make sure that you didn't do that. But it's not something that we try to enforce in the module because I don't think that's the right way to do parallelism. I don't think it's good. That said, I do wish programming languages helped more with parallelism, and you know, it would be interesting to see what we can do, but I only have so much time. Okay. So we're gonna just make this a single file module, I think. Just move the whole file. Oops. Okay, which means we're going to go to build here, and we're going to import Treemap, and we're going to not load this, and we're going to go get sort. Actually, sort is in. Why did I put that there? We need it here. Right? Probably like basic, yeah. Oops. Is that really the only files? Oh no, there's this one. So we have string already. We put hash table there. All right. So this is fine. Let's make sure that builds. Nope. Examples Treemap file. I didn't save the file, dude. Okay, vector 2 in Treemap. Import math. Import math. It might not be worth having these be vector 2s. We'll do it for now, but we could make an interface there or something. Import. Why am I having such a hard time with such basic things? Import. Bucket array. Okay. Can I get away without that? Yep. Yep. Okay. That's great. Let's take the W. Actually, we'll go to the changelog. Added modules Treemap for generating squarified tree maps and examples Treemap showing how to use these. Examples codex view now has a Treemap view of your program. I mean, that's to be added, but we're getting ahead of the gun here. Commit added modules Treemap. Boom. Do I think it's reasonable that modern operating systems use automatic reference counting to manage virtual memory and OS objects? No. No, I don't think. Like, none of that, that's all bullshit anyway. Like, your operating system should not manage files. It should not manage Windows. Those are not operating system things, really. Like, here's the thing. Well, it depends on what you mean by automatic reference counting. I mean, yes, when your process crashes, those resources should get freed, right? So there's no question about that. But like, should that be the API that you provide? No, because whether I have a file open right now or not is a very important fact. And I want to know exactly when that file closes. I don't want it to like magically close because I forgot about it. That's terrible. That's just not how to program, especially in an operating system way. So it was batshit insane for any program to manage 100 objects, each with their own unique lifetimes. Other people said that's just how modern operating systems work. Well, I mean, if you're talking to Hacker News or something, most of those people don't know what they're talking about anyway. Oh, Handmade Network. I mean, I don't, like, again, isn't it the job of the OS to multiplex your hard drive? Yes, but that doesn't mean it manages files. Why does multiplexing your hard drive imply managing files? Wouldn't it be simpler if it didn't? Anyway, now my Emacs window is small. I can't control the size. Do I cook my own food or Uber Eats usually? I usually would go out to restaurants, but since I started disrespecting seed oils, I can't do that anymore. Because literally every food has seed oils in it. Okay, so let's go to Codex View. All right. Let's go look at the UI. So once I've got my Tingtangler loaded, we have this thing. And I would just like, I think a first cut would be to provide an alternative just view of the same data. And then, you know, later we could talk about if there's different data. So in this very rectangle, where we draw this, we would draw the tree map. Now, I'm already starting to get a little sketch about this. The reason being that, like, I feel like if you put this much stuff in a tree map, it's going to be hard to see. Like, how could it not? That said, maybe it's fine. Now, we would have a couple of controls in common with this. We would have not constant, because that wouldn't work, but we could have linear and log size for the tree map nodes. We wouldn't have sorts like this. There would be no sort. It would just be in 2D. And but we would have metric and we would have bar height or square size. And we would have include modules. So yeah, I don't know. I also have the zooming. Yes, that is true. It is true that we have the zooming. So I feel like we're going to want to refactor this a little bit. But let me go into Codex View. And I think it's called Graph. I want to look for who says primary sort. Who says that? Draw metrics. I don't know. Okay. We're going to call this draw metrics. So we have this graph region down here. Okay. And then draw graph rows. Okay, so if graph type is equal to rows, what is label color? You know, we'll keep the label color out here. So we're literally just going to do this, draw graph rows, else if graph type is equal to dot tree map. We're not going to do anything yet. Okay, so in graphs, what is happening? Graph rows. Okay, cool. Cool. This has a bunch of stuff that we might move around to share. Now, we're going to want to define that, right? So graph type is graph type, right? Graph type is enum u8 rows tree map. Okay? Okay, now, meow. Meow. I don't have my Emacs in the right place to open the files. Okay, so who's drawing these? Primary sort. So we do a label drop down stuff. Okay. So we're going to keep all this same stuff. The metric choice drop down. Okay. So if graph type is rows, we're going to do all this stuff, right? And we're going to go else tree map. We're not going to do anything here. Except we're going to keep the metric one exactly where it is. Okay, now, what else? We want to move these primary sort and stuff over and minimum size. So R is See, metric is on the right. Label width 1. Plus sort margin. All right, so label width 1. It's going to be equal. I don't know. This is kind of random. I do feel like I want to have a secret mode that you can turn on where you can see all the rectangles, and then, I mean, maybe we can even make it so you can resize them. Okay, so this is moved over now. We'll move that out over even more. Okay. Sort margin is label width 1 plus right drop down width, I guess. Okay. So now we're going to want see, this is on the right-hand side, which is weird. Okay. The drop down to pick the view mode. All right. So we're going to go D is get rect plus label width 1 divided by 16. I don't know. Region.y plus top y. Plus, okay, and then DL is dl.x minus equals label width 1. All right, let's just put this in a thing. And then we're going to go drop down for D and DL for the label. And this is view mode. Okay, and this is graph type. Okay. And we might make this a different color drop-down eventually, but for now we just want it to work. So this isn't metric names, this is view mode names, or graph type. Let's call it graph type names. That's the internal name for this. Now what do we do? Okay, so this is weird because we have this data-driven thing for metrics, but rows and Treemap. We maybe can find a better name than rows. Okay, left drop-down width is not. right drop down with. Okay, graph type, wanted pointer to S32. Oh, geez, really? I didn't want to make that polymorphic. All right. Actually, drop down. I don't know. I don't think we changed the value there. Okay, so here, drop down, label, graph type. That's GT. That's GT. It's like FT, the fuzzy tomato. All right. So, oh my God. Oh, I loaded. Okay, this is messed up, but fine. We actually could use the other one for the drop-down size. Right. I didn't do this part. Okay, and then this is going to be left drop down width. Gonna set this out here so as we could use it. Okay, so we certainly could be picky about the positioning of this, but we don't care that much right now. We just want to be able to go to Treemap like this and rows. And include modules weirdly is there. Let's get rid of that for now because it's not supposed to be there, although we might want to bring it back. Include modules. Okay. So, rows, Treemap. Rows. Okay, cool. Treemap. Metric, still there. Boom, baby. Okay. Now comes the magic. The Magic Johnson. Magic Johnson. Now, well, draw graph tree map. All right, so we're going to go, just call it draw tree map. We're going to have a file here. What? Oh, it's called graphs. Graph rows, that's what I was looking for. So we're going to go tree map. Okay. Current proc info. Null. Okay. Treemap initted is false. All right. Treemap is a treemap. Treemap or display is a treemap display. Okay. If not treemap initted, then we do the things. But first, let's make sure we load this file. Dude, Emacs. Import Treemap and add that. And now we build draw Treemap. Because I can't decide. Okay. Here's what we're going to do. We're just going to go for it, guys. We're going to fucking go for it. All right. Treemap initted is true. What? Oh, we're not going to go for... Okay, fuck. It's not that easy. We'll do one thing at a time because I want to get rectangles on the screen. That is getting rectangles on the screen is of paramount importance. Here's what we're going to do, though. We need some kind of a tree map. If dirty, so we want to recompute if dirty. Actually, also, all right, so outer size is a vector 2. Recompute if dirty tree map, right? And then recompute if dirty display and rect or entire region .w entire region .h. That is just how we do it. Okay, and then we're going to go to our examples tree map main, and we're just going to draw some stuff. We're not going to duplicate everything. We'll bring the zoom and stuff over, but like I said, we might want to make that into a getRect widget actually. But I kind of want the example not to use getRect because I want people to know that they're not tied to each other, right? Okay. So we're just going to, this is also called draw a tree map. And we're just going to do this. And we're going to say T. This is just going to be matrix 3 identity for now, but we're going to keep the transform in there. And we need the cursor. We need the center. Right? Well, we don't need the center yet, right? Nobody uses that. We do need the corner. So the corner is going to be okay. And then we're doing our transform. And we're drawing our simp. We don't really set shader for color here. So that's great. And then the color is going to be based on the metric. All right. And actually, we can just have one for now. We may want more later. Color is get color for current metric. Okay. How do we get the metric? Well, for now, we're going to pick a random number, and then later we're going to use the user data. But the goal is to get rectangles on the screen. Metric low is 0.0. Metric high is 10.0 or 1.0. Metric mean is random get within range metric low metric high. Hopefully that makes things different colors. I don't know. Okay, what else? These, okay, these can go here, obviously. That can go. Corner. Right. And then instead of current node, all right. We will add the hot picking later on. And okay, how do I get the mouse? Cursor, pause. Okay. Let's just do this. Okay. What do we got to do now? X0, undeclared identifier. P0. Oh, P0, P1, P2, P3 is get quad entire region. Okay, Treemap Display. Right, because I just called it display. Maybe not a good name in the long, you know what? Just call it, so now I need to change these, but like, look, it just lines up nicely because it's the same number of letters, but you know, that kind of lines up a little bit too. Okay, proc.metric. What is proc? Proc, oh, wait. Sorted proc subindex. So this is a, oh. This one is the random one. Okay. Well, buddy. What's, oh, recompute if dirty. Bam. Oh, because I didn't add anything. There's literally nothing. There is literally nada. Nada surf. It is the singularity has arrived, but it is the singularity of incept treemap data. Okay. That sounds fancy, right? Now, for all the modules, I don't remember the program representation here at all. So header. Oh, this is right. This is in modules, codex view, or codex, read module, read module, header record, num modules, module record, file record, okay, procedure record, metrics, okay. So num modules. Okay, so make, oh, codex help. I just, my brain said command line help, but no, this is the thing that makes it convenient, which is great. Codex help, there we go. So we're going to go for codex help.modules. We're going to add nodes. The problem is they're all going to be size 0, so we're going to pick a random. Size is random get within range 0, 1. That's a node check-in. And we're going to say node is add node. Let's say module here. Right, and then node user data pointer equals module. We're going to have to, or may have to do some other things. But anyway, the node is going to be add node, wrong Treemap, add node, Treemap, the name, which is going to be module.name, I guess, and then the parent, which is root Holio, all right? So root is add node Treemap root null. All right, easy clap. Add mode, it's not add mode. It's a la mode. It's module name, is the name is not a member of module record. Okay, well, let's see what is. Module record. Module name. Decode. Is it? I forget. Do we decode this? What do we do? Decode. Yeah. Okay. It's not dot name. Not dot name. It's a dot Microsoft dot namenet. Okay. Boom. Boom. Ah. Okay. We're actually gonna have to look at this. I goofballed somewhere. It's probably trivial, but let's get this going. Examples, codex view. I should make this like automatically load the thing so I don't have to click on it all the time. And view mode tree map. Okay, so tree map. Oh, my display, I never assigned it, guys. This tree map display is not a thing. Literally, it is not a thing. Init tree map display. Cool. Not cool. Cool. Okay, let's at least make the view mode start out. Okay, well, we have no rectangles on the screen. I would like you to know that this is a wonderful victory for the Democratic Party. Okay, why do we have nothing? Why do we have nothing? Is the camera freaking out? No, it's fine. Oh, it is a little bit. It's an indie video game, guys. It's like, it's got the fake DOS console and then the static on the camera. Okay, now, what do we do? What do we do? We literally have no rectangles. I guess I'm just going to step, right? I'm not sure what units these are supposed to be in. Okay, let's... Where did I put it? Where did I put a graph mode? Type, graph type, draw metrics. Okay, so now we start in Treemap, but that actually, I actually want to step in rows. Okay, well actually, I want to start it over here. Okay, browse, and we're gonna go to draw graphs. No, not there. There. There, okay. Okay, quad. Okay, so this thing here, what coordinates are these in? Q0, they're in screen coordinates. Great, that is good to know. Now we go here, and we open this puppy dog. This puppy dog. Treemap Display. Node 76. It's pretty honking big. Oh, because it is the root node. That would explain. Okay, anyway. So we're going to go here. Going to go here. What's the color? That's the first thing, that could, not the first thing, but it's a thing that could be wrong. This is a color. Okay, great. What is P0? P1, P2, P3. Okay. They're all literally size 0. They're all literally, wait, I set the size. Didn't I? Did I not when I said incept data? No, I didn't. Bro. I thought I did. Okay. That's it. That explains why there's nothing. Hey, check it out. It's a wonderful tree map with randomly generated colors. It's great. Okay, the thing is, this is just the modules. And we need okay. Node.user data S64 is XX node treemap node type dot module. Module file procedure. Those are going to be the things that we pack in. Now, into every module, for every module, there must be some file. Actually, that's not true. Not true, but I don't care. Module from codex. Yes. Okay, so for file codex help.files, we're also gonna do this. Actually, we might be able to get rid of that eventually. Node is going to be add node. Decode file dot fully pathed file name. All right. And the module is going to be, okay, well, here's the thing. We need to get the tree map node from the, okay, so table add modules nodes, right? The key is going to be module and the value is going to be node. And we're going to have file nodes. We're going to have module found is table find module nodes module node table find module nodes modules file dot codex help dot modules sub file dot module index. Okay, assert found If not found, continue, because fuck it. Node is add node. Node.size is size. Don't forget that one. Node.user data pointer is file. And then this thing is going to be treemap node type dot fileholio. Now, file nodes, file node. Okay, well, module nodes is a hash table mapping module record to treemap node and file nodes. Dude, hash tables are so OP. Like, I never used them that much in C++ because C++ is terrible for this. Oh, it's just table. But once you have good ass hash tables that are easy, I mean, it's like the way people in Python or Perl use hash tables all the fucking time. It's like, I do that now too. Hey, there's more smaller squares, guys. How do you feel about the more smaller squares? Unordered map is fine. No, unordered map is only if you get STDs, which I don't get STDs when I program in C++. Is Python dict a hash table? I'm sure, right? Standard shared. I don't use STDs, guys. I simply don't. Actually, I started using std : function at one point, and then I stopped because it was itchy. Okay, so procedures. Here we go. So for proc codex help.procedures. Okay, this tells me the file index. All right, file node found is file nodes codex help.files. See, it's almost like this is a good binary file format, guys. Jesus. Proc dot file index. All right. It's almost like this was designed. Okay, now node is going to be add node to the tree map. Procedure name decode proc.name. Oh wait, did I add to root? I messed up here. This is not root. That's why it didn't look like a super. This is module node. Okay. And then this is file node. That's the parent. Okay. And then size, node.size is size. Node.user data pointer is proc procedure. Okay. Table add. I mean, we maybe don't need this for now, so we won't. Okay. Browse. Kabam. There we go. That's the future, everybody. The matrix has you. Okay. I'm sure the Twitch compression algorithm is doing amazing. Okay, but, and it's a big but, now we can start getting a little bit more real. So I'm not going to init these sizes here. Okay. They're just going to be, let's make sure that works, in the files. Okay. And now the file sizes, instead of being random, it's going to be proc.num expressions. Okay. See what that does. We've just got to figure out what Chunky's deal is. Hey, that looks more like an organic situation. I wonder what that giant ass thing is down there. Why is there a giant fucking giant thing? That makes me worried. Okay. Yeah, I think we're going to need the zoom, but we knew that. Compression status nasty. Yeah, we didn't drop frames though, so GG. Okay, so we could add this to procedure nodes, but we are not. There is no such thing right now. Now, those colors seem pretty random. All right. So, metric. Okay, the low, mean, and high, those are actually globals, right? Yes, okay. So we just need to get this. So color is a vector 4, if node dot user data s64 is equal to treemap node type dot procedure. Okay, then proc is cast to procedure record of node dot user data pointer. Okay, otherwise, and we'll do some things in here. All right, don't you worry about that. Otherwise, we're going to go color is dot point 2 point 2 point 1 point 1 point 1 1. All right, cool. Now the metric is going to be proc.metric. User data S64 is not a member of display node. Oh, node.node. Node.node. We love us some node.node. Metric is not a member? What? Okay, how do we get to it? Procedure record. Oh, we need to get our procedure for this procedure. Okay, so this is fun working on this program. I haven't worked on this program in a long time. I'm in a good mood. I was in kind of a grind mood today because of how much of a debug session the last thing was, but all right, proc.metric. We say M. Here's where we update wait, what is this? Draw graph footer, no. Get color for current metric. Is I guess, I don't know, let's just see. Wait, no, that's not metrics, right? So this is a different thing. This proc was gotten, it's in sorted procs. How do we initialize this? Here we go. For codex help procedures, we array add to sorted procs. Okay, but We don't have a map from that, do we? Table. What's her job? Tables. Okay. Sorted procs. Okay, proc to proc info is a table from proc to sorted procs index is a table from a pointer to procedure record to S64. Fine. Okay. Table reset. I'm just going to type it. Proc to sorted proc index. All right. Now, for sorted procs, actually, as soon as we're done sorting, okay, this is weird. This is weird because this sorting is not something we want to do. This sorting is an artifact of, or it's a mechanism by which the pip graph thing goes. So where do we do the metric thing? That's what I want to know. Okay, hold on. We might want this, but I don't think we do. Metric equals item.heat. Oh, the record. I forgot you can record in the... Oh, dude, there's so much cool shit in this program, and it's only beginning. Okay, metric equals update metrics. For the memory, oh, this is for the memory. Okay, that's why it's called live allocations. Procs is a proc info. Compute metrics. Current metric info.record. Aha. Aha. So we go back to Treemap. Okay, we say metric is current metric of, and speed, store this, but whatever. Current metric of proc. That's it. That's all we got to do, right? No, current metric is not a thing? What? Current metrics is the metrics. Current metric index. Okay, so let's... That might be something that we want to centralize. Okay. Okay, I took that out. I took that out. No big whoop. Procs. Prep global bound metrics. What the fuck was that for? This is for proc infos. Oh. Okay, wait. We computed these metrics on load. Okay, hold on. Hold on. Info.record is it. Okay, but where do we compute the if depth? Is that, do I store that in the thing? Proc.met, yeah, okay, that's stored in the procedure. Like, literally, this is annoying. I'm just going to do this. I'm just going to do this. Cleanup, we only need this one so long as we have that other array, which we do. Oh, by the fucking way, this is just going to be codex help dot procedures, right? And we can just do that same thing on the other thing, I think. Okay, so for proc record.proc, and then info.record just becomes record. Boom, boom. Whoops. Went a little too far there. Okay, so we're not going to worry about fixing the other one yet because we want to get this working, but we will when we want to take the W. Okay, record. Oh. Yes. Okay. Proc.metric, right? Get color. Where's that? Dude, there's so much stuff flying around. Metric, get color for current metric. This is just metric, dude. It's the metric system. Learn the metric system. Hey, look at that. That's my program, guys. As of a few months ago. We don't have zoom capability yet. We certainly will want to add zoom capability. Bottom left, a big boy, I know. Okay, well, here's the thing we can do now is we can go from the node to the procedure. So we should be able to do the hovering now. That should be easy. Okay. Let's we'll draw an outline afterward. So where is that? New current node. That's not, okay, what's it called? Cursor pause dot. Okay, draw graph rows. Current proc info and current proc rect. Get rect. Okay, so current proc info is what we want. If we're inside this, okay. So all this stuff here even can just go in there. This is the only time we're drawing stuff right now. And then this current proc info is really just this here. All right. Type mismatch. Wanted pointer to proc info. Motherfucker. Let's see. Current proc info. Draw graph footer. Record. So we don't use the proc info at all, right? No. So let's just do this for now. Do we ever use current proc info at all? No. Let's just get rid of that. Current proc record. Oh, we do. Fuck. Fuck. This is hella annoying. So we use it here to draw the blend score. And that's something that we probably want to maintain. That's really the only time that we need it, but you know what? We do need it. All right, so here's what we're going to do is we're going to make an array of proc infos. Parallel when we load the tree map. Treemap proc infos is an array of proc info. We're going to go array reset treemap proc infos, and then we're going to go array add treemap proc infos, and info.record is record. Okay, so remember that no check-in thing that we even did? Well, that's the other no check-in. Proc to sorted. Okay. Okay. So we're going to compute metrics on that. Did we ever compute metrics on this? Anyway. compute metrics. Treemap proc infos. Okay. Problem. Do we have the index in here? File index. The procedure doesn't save its own index, which honestly would help. But we're not going to add that right now. I don't want to work on the file format. All right. So we need to go equals. So proc found or info found is okay, hold on. Wait. That's the wrong current proc info. What am I doing? Was that other one at line 89? No, I don't know what I was doing. Okay, so here we're going to say info found is table find proc to treemap proc info, right? And then proc. And if found current proc info is info, all right. Proc to treemap proc info is table from procedure record to proc info. It could be the index, but we're even just gonna fucking do it. All right, so for these will no longer be added to, so we can just put the pointers into the hash table, the hash Diablo. So table add proc to treemap proc info. The key is the proc, which is it.record and it. All right, that's, you know, it is what it is. Info.record is record. That's proc. Okay, compute metrics, treemap proc infos. Oh, right, literally right there. Literally, okay, if current proc record, undeclared identifier. Right, because I was going to change, what did I do? That was short-lived. All right. Did I do everything? That was pretty random. So, hey guys, check it out. Patch intrinsics table. Holy Jesus. I just have to look at what this is. Like what? That's just insane. That's insano balls. 45,000 expressions. Array reserve. This is a bunch of polymorphs of array reserve, I think. Pat line 1027. Okay, that's oh, I see. Oh, okay. No. Why is it called patch? Oh, was that a macro? No, patch. Why does it think this is what's big? Okay, we're going to have to investigate this. Oh, this is a pretty old image. That said, yeah, maybe this has been factored a little bit. That's also why the line number doesn't match. This is a load of a file that we dumped. I mean, the timestamp isn't even going to say because the laptop's newer, but let's find out. We should make a new one sometime, but December 19th was the last time that we updated this, so we could make a new one. All right, I'll be interested to see how this changes, but before we do that, dude, so much fucking polymorphics. Look at all these polymorphics, dude. There's like a lot. We need to do something about that. I have ideas, but all right. No, this is cool. I mean, honestly, this is enough to feel good about ourselves tonight. We'll keep going, right? But since it's been like an hour 45, we'll take the W. You're not allowed to Pomodoro for more than 15 minutes, so, there is that. Okay. Let's look at let's look at the other thing. Codex view. This is also an old image for Codex view, right? Print type to builder. I mean, this is a pretty simple program, relatively speaking. So we can also do the shinies on here, by the way. There's some stuff that we can do. Because you kind of can't, it would be easier to see all the little blocks if we put the little shiny on it. And the easiest thing to do is to just make a little texture map that we plop on there. Okay. Borders would be difficult. I don't think they would be. But first, what I want to do, I just want to highlight the thing that your cursor is on, right? So when we're in row view, see this? We have a little cursor. I want to do the same thing for Treemap View because that just helps a lot, right? Metric, heap allocations, boom. Metric, global reads, maximum loop depth. This is pretty cool. I like, this is dope. It is dipe. Our functions now leaves in the tree. Yes. Yes. Okay. Any other questions about what we're doing here? Maximum if depth. 0, 9. I kind of want to zoom in already, dude. Let's just see what happens. Like, I'm a little bit, I don't want PowerShell, please. Why are they trying to do that? How do we do it? Oh, just codecs. Dude, I don't know how to use my own compiler. It's just, yeah. All right. So now we're writing the codecs view. Where'd it go? We didn't write the full thing, the full file name. Oh, it's probably in Sokoban source exported. There we go. Okay, so we're going to go to examples, codecs view, whoops, run, and we're going to put this in here. All right, and now, hey, remember this? Now we're going to run this, and we're going to load that, and we're going to hope it's all fine. There we go. Okay, well, this is weird. It still thinks this function is really big. Oh my God. It thinks that function is 100,000 expressions? There might be a bug. Or maybe the compiler's kind of going insane accidentally. Like this could be a good way to find compiler bugs. The fact that this is possible in less than 2 days is so OP. Well, thanks, man. I have been working on it for a long time. You know what I'm saying? This is, you know, this is like investment coming to roost. These are WI's bindings or something? Why do they have so many expressions? Okay, I feel like there's a bug here, but I don't know if the bug's in the compiler or in loading these things. If it's in the actual things, we could check. I do feel like this is probably a bug in the compiler, and that's actually good news in a sense, because maybe this is why the compiler got slower. It's because you know, these look giant, but you know, um, you know what I'm saying? Zoom Funk, yeah, I need to take a 5-10 minute break. This has been, we're 2 hours into this stream, and today we already did like an almost 5-hour stream and then another 2 hours. So this is like 9 hours of stream. It starts to take a toll, but this is a pretty good, like, this is just about enough to make me happy for the whole weekend project, and I haven't even worked on this tomorrow yet. So first we're going to do highlight cursor, and then we'll port over the zoom and stuff. Dude, this is so dope. I can't even. Yeah, patch intrinsics table. So here we do this on like a log graph, so this doesn't look that big, but like 42K. So here, 100K, 42K, 30. I'm looking at this number down here, the size. 100K, 42K, and then 4K. It's not a surprise that we didn't notice how incredibly much bigger these are. I mean, I guess we could pick bar height linear. Okay, now you notice. But it still doesn't stand out the same way, sort of. It just looks broken, right? Whereas here, it's like, okay, there's a giant ass rectangle. This is like our Maya files right here, except smaller. Okay, do I get another? These teas don't have caffeine. I don't know. Let's see. Let's see. You know, I kind of want ice cream to celebrate, but I'm kind of full. All right. If I use square root for the row view, it will be close to feeling the size. Well, you have to like square root and then normalize, I guess. Yeah, that's something we could look at later. I don't want to rat hole on that now. Okay, so let's make this a little bit more. Let's just look at this just to see. Okay, so first of all, actually, let's make sure this line number. It's so funny that this was big last time, and now there's this. All right, subcommand service render SL parser. This is line 1067. And that's the right location. Why does it think this is so big? There's a for loop. No, that's just a regular array. Like, this is so weird. Like, why does it think that that function is big? If anything, I would think that this get intrinsics is big. But that runs at compile time. What, can we find get intrinsics? I should have a thing that search by name. I wonder if we're somehow misattributing the expressions, but even like 42,000? That's not right. Like, this is only, okay. This goes from line 772 to 1060. It's 300 lines. So it would have to be 100 expressions per line. I wonder if there's something with all the nested procedures. All right. All right. Anyhow. Let's look at this one for a second. UI init. Line 328. It might not be, I mean, this looks kind of big. I feel like there's a bug in the compiler that's causing us, when we yield, to do a bunch of extra nodes. And that this is bad. And I feel like if we had a little visualizer for, you know, for the function, we would be able to see what the problem was. Okay, anyway. For now, not gonna worry about it. We're working on the UI. This is cool though. Dude, I like looking at this. I'm sure I'll like it more later, but okay. Next, oh, well, no, we took the W, right? Yeah. So, in graphs, we say current proc info, right? And we use that to draw current proc rect, current proc rect. Okay. So that's just there. So if we do this, current proc info, current proc rect is get rect from like that. That might be enough to do it. Okay. Okay, so it is there. It is not easy to see. So we're going to change the color. Okay, proc rect. Okay, FG, FG, FG. What? What? Where's FG? Okay, we're just going to do the following. Okay, we're going to, if it's rows, this is FG. And if it's tree, we're just going to make it dark. And we might actually like strobe it. We're not trying to be too flashy right now. Okay, this is a little bit better. Bwonk, bwonk. These are all littles. These are all littles. Okay. We're not going to worry about tuning this for visibility yet because we're going to change the way this looks a little bit. I mean, this is going to be super cheap cheese that we do, right? But we want... Do we load any bitmaps here? I don't think we do, because otherwise we might use them for those buttons. Data, nope. All right, well, we're going to copy this from the examples. We're going to copy that terrible bitmap, and then we're going to replace it with something. Treemap. Wait. What? Don't we load? Oh, it's in simp, right? Image test. Oh no, that's the other image. No. Oh no, simp is just, never mind. Simp is just doing RGBs. You know what we could do? Okay, this is what we're going to do. We're going to do cheap ass. Super cheap ass. When we go here, okay, we're actually, in fact, gonna do C0, C1, C2, C3. Okay. There we're just gonna be flat. Here we're gonna be vector 4. We're going to put those out of the... Well, no, we'll keep them in here. All right, so we're going to get this color. We're going to say C1 and C2 are color. C0 is color, but C0.xyz times equals 0.8. C3 is color, C3.xyz times equals 1.2. And plus equals 0.1. Okay, y, z. Okay, so I goofed. Yeah, we can't do that. This is not HLSL. my man's color. Okay. Hey, look at that. You can see the squares. It's I put the light source in the wrong place. Okay. But see how I'm saying it's more legible. We need to chill this out a little bit. Okay, so this C3 is all going to be C2. Okay, and then C0 is fine. C1 and C3. Okay. 0.85, 1.1. Okay. This is just a super color hack. This is not a high quality exercise right here. Okay. That's a little nicer, I think. It no longer looks like Digicam, but you can see the things. Look at all these little guys down here. Arr. Arr. Maybe grow. Array reset. Array add. Oh my god, we have so many array adds. Holy cow. This is the whole Sokoban game, guys. We actually, we should put the include modules checkbox, right? But yeah. Okay. Like, how much money do they spend on Visual Studio? Never mind. I'm not even going to get started. I'm not going to get started. Okay. So, visit files. 2 days. It was mostly today. Like last night we had one stream, right? Okay, so we're going to put, we're going to take this W, and then we're going to get the zoom and stuff back. All right. And, you know, I don't think I'm going to do this tonight, but we'd probably add some options for like borders around modules and then borders around files, right? Sending data from the compiler to the viewer has been done another time. Oh, for sure. Yeah, no, yeah. Yeah. No, let there be no confusion about that, right? We're piggybacking also on work that was already done. But, no, all the Treemap stuff is totally new, obviously. Okay. I mean, this has been a great weekend project. If it were done here, that would be fine. But it's not done here. I'm looking for the brightness control. Like, why do laptops, why are they so cryptic about? I'm hitting brightness down. Brightness isn't going down, guys. It's we have 3 brightness settings. And they're all exactly the same. They totally broke it. I don't know what's going on. RIP. Is that keyboard brightness? Maybe. I don't see keyboard brightness changing. It does look like it though, right? Like that's a keyboard icon. But the keyboard brightness is not changing either. Oh, these are screen brightness. Okay, there we go. Yeah, it's impossible. Yeah. They recently fixed the volume control. Great. Isn't this like a five? This one's a little cheaper. This is like a $3,500 laptop. But yeah, yeah. Okay, so, well, we're just gonna add some input stuff, right? So here we go. It's exactly the same kind of a thing. So let's get from here. Just remember this stuff. Zoom, 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 north, south, east, west. Stuff for Treemap mode UI. We may want to just factor that. May want to factor it into there. But anyway, zoom target, mouse wheel. Oh, let's just get all this. Let's get all this. Boom. Get rid of that. Boom. Easy clap. Now, let's just make sure that compiles. It doesn't. 144. Oh, we called it event, which is fine. Now it does. Okay, great. Let's just start with zoom, right? Okay, we're going to want some move toward. I don't know what the current DT is. Yeah, I don't know. Okay, zoom current, zoom target, current DT. Maybe it's current DT. No, DT. Let's just do this. DT. Move toward. Oh yeah, we don't have that. We gotta get it. I should. Oops. Let's just put it down there. Yeah, that's fine. Okay. Oh, we're not using the zoom yet. We forgot that part. Or by we, I mean me. Remember this? Okay, so scale to relative. All right, so center is going to be P0 plus P2 times 0.5. We're going to do it that way this time. To relative, scale, and no offset yet, because that certainly was some agony, right? Scale times to relative. All right. Okay, well, it's in the corner. Oh, because we need the two worlds. We're just not going to do the offset part. All right. Okay. So, however, we're not scaling right now. Did we? No. Okay, we got the P's. We got the P's. So is it? I guess our zoom current, right? Oh, you know what? Someone might be eating the input or something as well. Nope. Zoom target is like what? I guess our DT is 0. That is my only explanation, is that DT is 0. And we never noticed. Yep. Okay. Y, current time minus last time. Current, oh, we have a current DT. Wait, what am I doing? Right? Oh no, that's not right. I've got so many files flying around. Current time, last time, current DT is a float 64. So current time is 2 float 64 seconds. Okay. Let's just do that. I don't think... I don't know why me. Oh, because we set it. Okay, this is the only window during which you could do that. I was a bad person. Okay. Okay. Here we go. Okay. There we go. Hey. Okay. We can't strafe yet, but we're gonna get there. Believe you me. Believe you me. We gonna get there. Look at all the little fellas. Look at all the little fellas. We actually maybe want to make the border thicker as we zoom in. Anyway. The computer is now blazing fast. Well, or blazing slow. So now, here's the thing, is we probably want to scissor this as opposed to letting it like, you know what I'm saying? So let's think about that. I mean, this is kind of cool. This is a little bit modern, if we had shadows behind all this text and stuff. That would be kind of dope. Okay, let's just scissor it for now. I kind of like this full bleed action though. Like, that is dope. All right, so we're going to scissor it for now. Okay, so simp has scissoring, right? Right? I believe it does. Set scissor. Heck yeah. Heck yeah. Wait, this is not, I'm like, feel like I'm using my C++ defer macro, right? Okay, here we go. Boom. Oh God. We're not always, we're like mostly scissoring, but there's a big difference between mostly scissoring and all scissoring. It's kind of cool though. Like, I might not rat hole and debug this right now because it's kind of fun. But obviously, there's a problem with scissoring in simp with the GL backend. Okay, but before we worry about that, because that's something we could do like tomorrow or something. Let's add the panning, right? 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 No, we already have that. So we're going to get this offset in pixels. This is going to be called Treemap offset in pixels. And right, and then we're going to put the offset in the basket. Okay, and then here we're gonna, I think we already got those. No. Okay, Treemap offset in pixels. Okay, so when we simulate, okay, here we go. We're just gonna choppy pasta this, and yeah, I do feel like this is gonna make its way into a getRect widget because it's just fun. We just need to figure out how to make it maximally usable. So simulate, all right, so Feast, Mr. Feast. Okay, so Treemap offset, and this is Treemap offset in pixels. Okay. Offset plus equals delta. Okay, oh boy, we really hit the jackpot there. Treemap offset Oh, window width. Okay. Yeah. Oh yeah. That's chunky. It's chunky. Chonkers. This actually feels a little bit claustrophobic now. Okay. We're gonna want to draw a background. Because when you sort of pan over, that's not great. Etc. Okay. Entire region. Okay. We're going to go inner is shrink entire region by, I don't know, right? Okay. Draw a rectangle across entire region because we might pan off it. This also serves as a border color for the shrink, due to the shrink operation. Inner. All right, so here we go. We're going to set shader for color. We're going to go get quad entire region. All right, and then immediate quad. I don't understand. Is this a different P0, P1, P2, P3? Yeah, anyway. Color. Vector 4 dot. It's going to be barely a little bit red. O dot 1.07.071. All right. No, no, that's not what we want. Okay. Okay, there's a little border around it. I would actually make that even a little darker. But now when we pan off, there we go. I'd also max. It's got to be at least 1 pixel. Max headroom. Okay. Max headroom. All right, so that's pretty good. Now, however, this scissor situation, it's like the scissor sisters are not here sometimes. So GL enable, GL scissor tests. All right, here's what I'm going to do. I actually don't, Set scissor does an immediate flush. Clear scissor, okay. So it's literally enabled the whole time. I kind of don't know what would cause that if it's enabled the whole time. Right? Like, Why are some rectangles exempt from scissoring? But scissoring obviously works. And we're just drawing all these in one loop. Here's what I'm going to do. I'm going to do this most horrible frickin' stupid thing. Okay, there's multiple horrible stupid things we could do, but here's one. Like, we're literally re-enabling, because there's going to be a flush at some point. Is it called GL enable? Okay, we're just taking a GL dependency, literally right there. Okay, that doesn't even fix it. Is this like a driver bug? Like, what's going on? How could something this simple be a driver bug? Do the chosen ones get mouse hover? Oh, actually, that's a good point. They will. Everybody out here will get mouse hover. That's a thing that we manually masked off in the other place. Okay, but see, like even the rectangle is being drawn elsewhere. Okay, we're not going to worry about that yet either. So the rectangle is not subject to the scissor. Oh, we're not doing an explicit flush. That's what's happening. So whatever are their last okay, easy clap. This is I'm a summer intern, guys. Fuck. We're not flushing, but then we're turning off the scissor when it's exactly like the other not flushing bug from earlier today, except not at all like that, except exactly. Look, bro. It's almost like I could program. At least I didn't take an hour figuring that out. All right. When I zoom all the way out, I don't know. I feel like there should be a timer where it drifts back to centered if you're all the way out, but like if you're all the way out and you zoom more, like, yeah, we'll think about that. Okay, this is coming out okay though, right? Wait, there was something I was gonna do that I forgot. Oh yeah, the mousy mouse and the funky bunch up here. So the way we did that in here is we said can pick. Okay. Okay, so we're just going to duplicate this logic here when we say can pick. All right. This is called inner here, I guess. And then can pick is only, there we go. Browse, ba-boom, babushka. But up here, look, nothing, nothing. Oh, there we go. We're still drawing the rectangle outside. Okay. I think we're just gonna have a separate draw function for that, for each one. I'm starting to get tired. So first we're going to take the W. Look at this, guys. This is baller. We had nothing yesterday. And now we have this. Okay. These are a bunch of little anonymous functions. Hash table? If I had my Emacs in the right place, I could just click on it. Oh, yeah, okay. So here's the thing. We generate procedures for assert directives, and we don't even mark them as compile time only, so they kind of just go into the program. So all of these are just like asserts, static asserts in hash table. Holy crap. And they're the same. Oh, dude. Yeah, see, this is what I'm saying about like, yeah, none of that should really be there. Especially because, by the way, this doesn't require a procedure to evaluate. Flags is a constant. Yeah. Yep. That's fine, though. Expand, I wonder if we could make that non-generic. I feel like we might be able to. Like there's a thing that I used to do in C++ all the time, which is I would make only sort of the interface to my data structure generic, and then I would kind of cast to a general thing, or a, you know. Like this is all bucket array stuff here. It's really more than I would have guessed, honestly. Like, that said, okay, we have established that we don't really know. We don't really know if these sizes are accurate, because we don't know about these. When we figure out about these chonkers, then we'll know if these sizes are accurate. But I kind of believe them. I kind of believe that this much of my program is bucket array, and that's a lot. And this is new. Like, now, if you looked at a C++ program and said how much is generics being instantiated over and over, it's probably like 90%, right? So this isn't that bad. But it's like, yeah, we really should. I mean, this is the thing that makes me sus. Maybe this is just a really horrible compiler bug. I kind of believe it. I kind of believe it's a horrible compiler bug. Because if I look at this, this is just going to be like a one-line binding or something, a binding of Isaac, right? Windows line 3551. Oh, no, it's a run directive with an ass load of asserts. What? Okay. Well, that doesn't necessarily have to go 5360. Okay, there's another one. So this must be output of the binding generator, right? And it's an interesting question if something is marked as compile time only. Maybe there's a flag for include that or not in here. Because look at all these runs, dude. This, I need to talk to Raphael about this a little bit, because the thing is, you pay for these runs when you compile. So like on the one hand, it's good to have them. On the other hand, You know, I don't know how much compile time that's necessarily taking, but it might be non-trivial. So I would prefer if there was just like a check parameter, like a module parameter to like check the bindings. And then only do these runs if that's set. Because that's what frickin' all these are. It's like so much. I don't understand how it's so much compared to the rest of the program is sort of my problem though. That's why I think there's a compiler bug. What are all those assertions? Well, this is auto-generated output, right? And so like we know what the offsets are supposed to be, you know, of the struct members and stuff. And the sizes. That said, I don't know why we don't just have a function called check offset and size. Like, you know what I mean? That does both of these. And then we wouldn't have all these frickin' string constants all over the place and stuff. But like, here's the thing. How many expressions is this? I don't know, 100? It's not, well, let's look at, well, I don't know which one we're looking at. This is line, Emacs doesn't know what line we're on. We're on line question mark, question mark. It's the year 2023. Okay, this is great. Dude, the fact that we could see the program and see these problems. Dude, if these are why the compiler is slow, I'm going to be happy when it's fixed. Oh my God, Becky, look at her butt. Okay, we're not going to fix these rectangles right now because I'm tired. I'm going to take the W and go to bed. This has been great, though. This is, like, look at this, dude. Look at this. Look at that. And, you know, maybe tomorrow we'll add some, again, some checkboxes or some drop downs for, like, borders around things. Like around modules and files, right? What do colors mean? The colors are hot or cold or medium according to whatever the metric is. Right now it's on blend, which is like a generic code quality metric, but you could pick out different things. So you could say, who heap allocates in this program and by how much? And these are the people who do that, right? You could say, who has deep loops and how deep are they? You could say, how nested are if statements, right? You could say, who reads global variables, by the way? Relative to the average. Who writes global variables relative to the average? You get the idea. When you call functions, are they close to you in your same module, or are they in a faraway module? So like this WIs, it's fucking calling out all over the place, right? Yeah. Is square size always file size? Right now it is always the, it's not exactly file size, it's number of expressions in the function. But, you know, that's approximately size. Could you make it something else? Yes, you could make it something else. It's just always a question, I don't know. It's just always a question, like, is it actually helpful? Because I could spot hot things on this map just fine, right? I can zoom in on them and say, what is it, right? Gamer. So, all right. Commit. Treemap view in Codex is getting pretty good. Code, I said pretty code, good. Now, one more thing we could do. Right, we could compile this with plug codex. All right, so now we have, because I updated the one for Sokoban, but not the one for Codex View itself. Here's what we're going to do. When was this one from? Wait, did I modify this? Hold on. Select this specific file, show log. I don't know why it says I modified that, but Codex View, wait, it's literally a year ago that we did. Oh my God. Oh, I guess I did regenerate it maybe right there. I don't know. Anyway, I was gonna keep records of it over time, but let's not. Codex View. All right, so now if we view it, we browse it. Now we're looking at our own program. Oh my God, UI init. It's giant. That leads me to believe it is a compiler bug, because if it was a weird, like, we output things incorrectly, then it wouldn't have happened the same on both programs, right? But it happened literally on both programs. And the other one that was giant in Sokoban, that function is not in this program. Gets bigger every time. Well, no, it's relative to the size of the whole program. So the whole program is this rectangle, and this is big, and it's 107,608, which is how many it was in Sokoban. So it's actually the same number of expressions. I don't know why it's that many. We're going to have to look at that at some point. Okay. That might be next weekend's weekend project. Oh my God, Becky. No, this is great though. I'm happy with this tool. We'll just zoom away from that unsightly rectangle. All right. I'm starting a tools company for $200 million and I'll sell it to Adobe. Oh, this is our math stuff? Hell yeah. Hell yeah, that's math. Math? Hash tables? Hash tables. It's really interesting how, because the algorithm is like, fill out a column, fill out a row, fill out a column, and it sort of makes these patterns, which is pretty interesting. Because these are like basically the same size, and they have the same metrics because they're all polymorphs of the same function. I don't know. It's interesting. Yeah. All right, everybody. What's the blend metric? The blend is, it's a linear combination of all these other things with some random constants that I didn't think that hard about. Look, at least there's not that many if statements relative to the number of expressions. All right. Dude, I'm going to have to take a look at that shit. All right. That's pretty good. Guys, I'm happy with, I have a lot of problems in all the work that I have to do this year, but taking weekends to do these little weekend projects has been really fun so far, even when it's been grueling, and it's going really well. And yeah, like we could be done, but we're gonna do more stuff on it. Can I show you the UI in it? I mean, I did. Where is it again? It doesn't look like it should be that, not remotely that big, right? UI init. Okay. So it's just, the thing about, it's got a static if, all right? So that's maybe a little bit sus. If there's a bug in static if handling, I mean, it's got all these regular if statements, but those aren't that big of a deal. And then it's got some assignments. Oh, God. I know what it is, guys. These are a bunch of bitmaps, okay? These are a bunch of bitmaps. And I was all being cool about it because I'm like, we're going to run get global data. And get global data is going to load the bitmaps, and then they're going to be in the executable, okay? These get turned into array literals of arrays of bytes or something like that, okay? Each byte is an expression in the array literal. We are exporting this entire array literal probably to the meta program because this is a constant and we link you to constants. So this is a fucking gigantic procedure because we're referring to array literals. Now, is that a good idea? I don't know. Maybe the expression size eliminates nodes in literals. Like, I don't know. I'm not sure what to do about this. But at least it's not a weird ass compiler bug. It's like, okay, we kind of know what's happening here. Yeah, I mean, the thing is, it's a little bit strange because, I mean, are we doing that for other functions too? I hope not. Like, what are we doing that for? I don't think we should export the array literal in these cases. I think we should just link you to it. But we have to. I mean, there's this question of like, do we add some complexity to the compiler by saying, oh, this array is a binary blob and you can't introspect it. But what if someone wants to, right? All right, well, now there's not even a mysterious bug. I mean, I assume that what's going on with that other thing is similar, that other function, but I don't know. Aren't those globals? Why do they get assigned? It's not that they get assigned. It's that, well, it is that they, I guess that they do. That's kind of the mistake, right? Like when we send you an identifier and it maps to a known symbol, which is most identifiers, we give you a link to the resolved declaration. And I guess it's true that we're somehow accounting that as being in here, as opposed to in its own thing, which it is. So that's not good. And maybe it means we're exporting it multiple times, which would also not be good. So that's a thing to look into. Yeah, it's true. It's true they should not count for procedure size here. All right. Thank you, everybody. I'm going to bed. We got a good things done today. This was a productive use of time.